Hi, this is Dr. Wolf explaining page 8 of the Chapter 10 notes so that I can show you how to work this Chi-Sqaure Goodness of Fit test on the calculator. So in this first exercise, 8, about coffee, we have a researcher claiming that the number of cups of coffee U.S. adults drink per day are as distributed as shown in this figure. So in this pictogram, we have a bunch of percentages shown about coffee drinkers. We're going to randomly select 1,600 adults and ask them how many cups of coffee they drink per day. And we'd like to see if the sample of 1,600 adults matches these claimed distributions in the pictogram. So that's how we write out HO, the proportion of adults who drink 0 cups, 1 cup, 2 cup, 3 cups, 4 or more cups are these percentages specified in the model. That's our claim, HO. The distribution of percentages is not as claimed as the statement we write for HA. Now in part B, we draw our critical region for Chi-Sqaure. This is a new distribution for these significance tests. We're using alpha equals 0.05. We have degrees of freedom equal to the number of categories minus 1. We broke our core coffee drinkers up into 5 categories, so we have 4 degrees of freedom. 9.488 is the critical value you can find on the Chi-Sqaure table in the beginning of the notes. This distribution is skewed right. The critical region's always in the right tail. There is no two-tailed test for Chi-Sqaure. Now, the observed counts from the survey of 1,600 adults are these numbers 570, 432, etc. And what we have to do is get the expected counts. So if this model is correct in this pictogram, 36% of 1,600 is 576, would be the expected number of drinkers of the 1,600 who drink no coffee. Then we have 1,600 times 0.26, 1,600 times 0.19, etc. So now what Chi-Sqaure is going to do is it's going to figure out how large the differences between these expected counts and these observed counts are, and if it's large enough, we can reject HO. So this statistic has the form summation O minus E squared over E, and we're going to show you how to do that in the calculator right now. So you have to go and press your Stop button, get into your list editor, and in list 1, make sure it's clear, and list 2, make sure it's clear. List 1, we're going to type the observed counts, 570, 432, 282, 152, 164, and then in list 2, we have these expected counts, 576, 416, 304, 144, 160. Okay, so please have those typed in list 1 and list 2. In order to get the Chi-Sqaure and p-value for our significance test, same menu we've been in the last couple of chapters. You press the stat key. Go to the test menu, and let's go up rather than down to letter D, Chi-Sqaure GOF Test, Goodness of Fit. We want to see if these distributions fit the claimed model. So now notice the test is expecting us to have already entered the observed counts in list 1, the expected counts in list 2. We have to tell the test how many degrees of freedom we have. In this example, it's 4. And then we calculate Chi-Sqaure. And as you can see, I got 2.81 and this p-value 0.5893. So, decision time, that's going to be a fail to reject HO. The 2.81 is not in the critical region, or the p-value 0.5893 is not less than the significance level of 0.05. So there's not enough evidence to reject the claim that the proportion of adults who drink coffee are as specified. So remember the language here, because the claim's HO, we say there's not enough evidence to reject the claim that the proportions are as specified. So in example 16 below, births by day of week, we have a doctor claiming that the number of births by day of week is uniformly distributed. So basically, is it just random, right? Random baby births by day of week, are they uniform? So here is data from 700 births. And what we want to know is, for these 700 births, if the distribution is uniform. So now for these expected counts in this exercise, It's much simpler than the one above. Uniformly distributed means equally distributed. So if there are 7 categories and 700 births, they should each be 1/7. So this symbol P sub I is just 1/7 for each of the 7 categories. If there were only 4 categories, I'd be taking each thing and multiplying by 1/4. So we have 100 as the expected count for each of those categories. HO, distribution of births by day of week is uniform. That's the claim. HA, distribution of births is not uniform. Then part B, we have 0.10 for the alpha level right here. And we have 7 minus 1 or 6 degrees of freedom. So let's go again, show you this calculator routine for the Chi-Sqaure goodness of fit test. So you start with stat, get into the editor, clear out any information from a previous exercise, enter the observed counts in list 1. So I have 65, 107, 117, 115, 114, 109, and 73. Okay, so now list 2 is just the number 100 put in there 7 times. No shortcut for this. Okay, press the stat key, go to the calculate menu, the test menu, go up to the Chi-Sqaure test, goodness of fit test, letter D. Select that, tell it we have this time 6 degrees of freedom, calculate Chi-Sqaure, and here we go, 27.94 with this p-value 9.64 times 10 to the minus 5. Please keep a lookout for these 10 to the minus 5s. So we have a very tiny p-value of 0.0000964, essentially 0. So we're going to reject HO and say that there is enough evidence to reject the claim that the distribution by day of week is uniform. Hope that helped. Please do the 4 exercises in section 10.1 for homework.